because I watched one class pretty much every night before I go to bed, just to see how the day was, etc. And I was like, man, this is so annoying. That's not full screen for you guys, right? So I made it full screen today. The beginning of the year was not possible.
100% of the year.
All right, so here we are. We are live. Here we go. Need pens or something, get it done right now. Doing a little bit of spring clean, getting things organized, getting stuff printed out ahead of time. I know a lot of you guys want to do retakes, and so instead of having to wait to print them out, I've got stuff ready and set over there. I got some USB extensions, so we don't have that thing hanging down anymore. I'm very, very excited. All right, so let's get this done. So we're going to prove that ABC and DEC are similar. Autumn, what do you think of the full screen? Better? All right. So what we're given is that these two are parallel. So AB is parallel to DE. Cool, cool, cool. So how do we prove these two similar? Well, we're going to need some angles because they didn't give us any information about sides. So how can we get information about angles? Go. Check it out. So the top triangle and the bottom triangle have a shared angle, and those are the triangles we're interested in. Now, on the grand scheme of things that are true but not useful, probably vertical angles, then linear pair, then shared angles are probably the most useless things, right? They can win you the whole thing, or they can be stuff that just takes up room on your diagram. So when you ever do a vertical angle, linear pair, or a shared angle, make sure it's actually about the triangles you care about. And if you notice, since there are only two triangles, and those are the ones we care about, they do share angle C, so that will be helpful. Don't talk about Danny like that. All right, so this angle is shared between the top and the whole thing. Nice shot. So, by shared angle, angle C congruent to angle C for both triangles. All right, so we got one pair of angles. What else do you see? Yeah.
Can I have
Yeah, you can. There you go.
Is it Isosceles?
Nope. It looks like it could be, but we have no information about the sides. We don't have enough to say it's Isosceles.
By cap C, angle CDE is congruent to angle CAB.
Exactly right. So when you have parallel lines, you should be looking for cap. Now, Noah's right. We can do both these angles here by cap and these angles here by cap. I only need one set, though, right? Because if I have one pair here and another pair there, I've got enough for angle. So I'll call it a day. But you could write both. Notice we have two parallel lines and a transversal cutting them. That's top right corner, that's top right corner, so these are both going to be cap, right? Cap says if the lines are parallel, the angles, corresponding angles will be congruent. So by CAP,
Does that mean we're using line CA?
angle CDE is congruent to angle CAB. What's your question, Danny?
Does that mean since we chose D and A to be cap, does that mean line CA is our transversal?
Yeah, so there's the two parallels and there's the transversal.
So we're discarding CB?
We're not discarding it. We're saying that we could do the same thing over here with a different transversal, right? And those two would be equal. They'd be different angles. They wouldn't be orange, right? But these two would be the same. Does that make sense? So even then we wouldn't know it was isosceles, right? Unless orange happened to be the same as blue, and we'd have to prove that. But yeah, either way works. The reason I didn't do both is because since we already have the shared angle that Coda pointed out, I've got a pair of angles here and a pair of angles there. Hello? Yes, I will.
I still have some random ones.
Anderson, office.
Very local.
Alex is gonna fail.
It's because he's wearing a shirt that makes him look like a strawberry. Nice. Get a green hat, my friend. All right. All right, so we've got double angle. So by angle similarity, these triangles are similar. What a chump. All right, big triangles ABC. Small triangles, the top triangle. Angle A in the big triangle is what color? Angle A in the big triangle is what color?
D.
That's not a color.
Orange.
It's orange, so it's going to go with D, which is the orange angle in the small triangle, right?
You know what I mean.
I knew what you meant.
5 days.
B is the unknown angle in our big triangle, right? And it will be congruent to E by CSP, but we don't care about that, right? We could also have done it by cap, right? We talked about that earlier. And then C is the purple angle in the big triangle. What's the purple angle in the small triangle?
How about we just do the first page?
Wait, C.
C, right? It's a shared angle. Yeah, they both use it.
Just the first page.
Yeah.
So the two triangles are similar, and look, that's what they wanted. We're done. Questions, comments, concerns, other than for my mental well-being?
What is a
No.
I mean, like,
What?
angle?
Shut up so I can hear Evan.
What's AA mean? Angle?
Angle, angle, yes. So, Evan, who was gone, we have angle, angle similarity is a way to prove triangle similar.
Yeah.
We have side, side, side. And then we also have side, angle, side. Now, notice we had no information about sides, so we couldn't do that.
What do you mean angle?
Angle, there's the first angle, and here's the double angle.
Oh,
So
okay.
in the top triangle,
So
we had
that's
these
the
two.
big triangle.
Yeah, we had these two, and in the big triangle, we had these two.
Yeah.
Right? For the sides, remember, we're not talking about congruent sides, we're talking about proportional, meaning that they all relate the same way. So if this side was a third of the whole thing, and this side was a third of the whole thing, they'd both be proportional, right? They'd be both related by a third. If this was half and that was a quarter, then they wouldn't be proportional, right? They'd be related by different things. So that's what we mean by sides for similarity. They have to be proportional, related the same way. So for instance, if I have a triangle like this, 3 and 6 are related by half or double, depending on how you look at it, right? So if I have 4 here, for these to be similar, this would have to be an 8, right? Relate the same way. They're both by double. If I had a 5 here and this was a 15, they're related by triple, which means the triangles would not be similar, right? So that would not work. What would that have to be for it to be similar? 10, because they all have to be related by the same thing. It's not enough to say, oh, look, they all relate somehow, right? 3 to 6, 4 to 8, and 5 to 15. They do relate somehow. All numbers relate somehow. The fact is that they all relate the same way that makes them similar. So if that was a 10, then they would all relate by the same way, half or double, right? Depending on how you look at it. And so they would be similar by SSS, right? Cool. All right, 2.
Wait, we proved it that fast?
Yep, BD and AE are line segments. That's all it's saying. So don't be fooled. This is a line. It's not bent at C, right? It doesn't bend down at all. There's not a slight deviation there. Okay, that means these two angles will be a linear pair. Same thing for here and here, right? B is congruent to E, they say. So I get this, right? That's what that means. And we want to get these parts together. Now we know that if the triangles are similar, then we can use CSP to get their parts, right? And get something like this. Now we're going to move things around to get multiplication instead of division. But that's the deal. Evan, what do you see?
By the vertical angles theorem.
That's right.
Angle BCA equals ECD.
Exactly. Now, vertical angles, linear pair, and shared angles are probably the things that you're going to see everywhere, right? There's a bajillion of them all over the place all the time, right? So the question is it going to be useful? And since these are the two triangles I'm interested in, and vertical angles gets me these two angles, an angle in this triangle and an angle in that triangle, yes, it will be useful, right? So by vertical angles theorem, angle BCA congruent to ECD. Again, can't call it angle C because there's two angle C's, right? In fact, there's 4. There's this guy over here and that guy over there as well. So we need to be specific. It's like when I have multiple students with the same name. I have to use last names too, full name, right? Yeah. So see that there's a cross here?
Yeah.
Whenever we have a cross, the angles here and here will be the same, guaranteed. And the angles here and here will be the same, guaranteed.
Oh, okay.
Right? Remember scissors theorem? Right, this thing? If I do this, they're always the
I
same.
thought you got it from the given, and I had no idea where.
No. Yep. Good question. Again, question that's this easy to solve, right? Because of a problem this big. Thank you for asking it. So now we have vertical angles. Do we have enough to say the triangles are similar? Yeah, by angle, right? It's our favorite. So by AA similarity, we know triangle, let's go ABC for the left side triangle. Whoops. ABC. Now angle A is the unknown angle in this triangle. We know that similar triangles have the same angles, right? So if that's green and that's blue, and that's green and that's blue, A and D must go together, right? In fact, they must be congruent. And we can prove that by CSP, but we don't worry about that, right? We're interested in sides, so I won't. But A and D will go together. Get out of here. B is the green angle in this triangle, so it's going to go with E. And C is going to go with itself because they're both the blue angle, right? Cool. Now we're not done. We need to get their parts together. Now, after we've proven the triangle similar, which we did, now we can use CSP to talk about their parts. Remember, it's like CCP, but with similar, right? Corresponding similar parts. Corresponding means same relative location. So see how A and B and D and E are in the same relative location? They're both first and second. then they should be similar. They should be proportional, right? So they're going to relate the same way that BC and what relates? EC, very good. Danny, AC is going to relate to what?
AC is going to relate to DC.
Nice, with the assist. All right, so all of those are related. Now, the question is, which ones do I care about? Well, I care about AB and BC. I care about CE, that's EC backwards, that's fine. And then DE, right? So I care about these two. So I don't need this guy, but that's fine. I'll use these two. You with me?
Yeah.
I'll use these two. And I'll move things around by multiplication. So I'm going to write it again. You don't need to. This time, I'm going to write CE instead of EC, just for alphabetical, because that's what I did up here. Right. That's totally fine. And then I'm going to move things around by multiplication. So to get rid of that CE in the bottom and move it to the other side, I multiply. Now, why do these things go away? Because what we have here is CE divided by CE. What is CE divided by CE? 1, right? And then we have 1 times BC, which is BC. So it goes away. It becomes 1, right? CE divided by CE, that's 1. And 1 times BC is just itself. So that's why it goes away, right? Now over here, we're not going to have that become 1 because CE divided by DE, that's something, right? And then we got to times it by AB. So CE divided by DE times AB. Multiplication happens in the top, so what we get is something like this. With me on that? Now, same thing to move over that DE. I'll multiply both sides by DE. Remember, got to do both sides of what? It's child abuse.
Whoa. It's algebra.
It's true, but it's algebra to do both sides, right? So, DE divided by DE is what we have here, right? That's 1, right? DE divided by DE. And then we multiply by the top. Remember, division, that's all it means, divide by DE, and this means times by the top, right? So I'm going to divide first and get 1. That's what that becomes. And then 1 times whatever's left over is just itself, yeah? Now I'm going to write AB first. Why am I allowed to write AB first? Why doesn't it? Yeah, multiplication, commutative property, right? 2 times 3, same thing as 3 times 2. Doesn't matter what I do, CE times AB or AB times CE. Did you ever see why those go away? Right, they become 1. All we're doing here is we have an option. Like if you look at the top, we can either times by BC first or divide by CE first. It doesn't matter. I divided first and got 1, right? And then times by the top. Okay, that's it.
Wait,
You didn't prove it. Oh, are you done?
Oh, right. Sorry, there's an error on this one. It should be AB and CE here. Change this. My bad. And then BC and DE here. As you can tell, I used the worksheet we were using to make the review guide. I do that all the time. I just forgot to change the letters up here. My bad.
okay. You can just do all that, like, with CS.
Shut up so I can hear.
You don't need to, like, write any other proofs down along the way, like.
That's all we needed to get there. Yeah, so we used CSP to get this, and then we just did math. Okay? Could you do multiplication property of equality? Yep, that's what we did here. We did multiplication property again, and then we did commutative to switch. But I don't care about that stuff. That's old. I don't want you writing me a book. Yeah.
Did you just do a multiply by C and D because on the bottom?
Yeah, and that moved them around to get the order, to get the multiplication that I wanted up here. Now again, I'm sorry that the prove was wrong. Sorry, I wrote the wrong thing up here.
Yeah.
Are you okay?
No, that still doesn't make sense because you put AB times C equals DE times D.
Oh, BC. Sorry. Thank you. Yeah, I was gonna fix it in between periods and I forgot. And then I printed 50. So
Fine.
on to number 3. So far, feeling good?
Yes.
Right, good. I show you the worst. That way, when we do the easy stuff, it's easy. All right, here we go. Angle C, which is this angle here, and angle DEA are 90. Now, could you get this other 90 by LPT? Sure, right? But again, I don't care about this shape over here because it's quadrilateral. Could you just put it down without writing LPT? Sure, I'll allow you that too, right? I don't care. At some point, we have to say, look, we all know it. Let's move on. I don't want you explaining every little thing. All right, so we're going to prove that these parts relate. Which parts? AD and BC, AB and DE. So, shocker, if you didn't see it, we have two triangles here, and we're going to get them similar, right? And we can do that. They're both right angle triangles, so the odds of getting that done is pretty good. We already have one angle down. Where's the other angle? They don't have a shared side. DE is not shared with both triangles.
No, I mean angle.
Shared angle, yep, and they share angle A. See how the small triangle uses angle A? And the big triangle also uses the whole angle A. Now, they do not share angle D.
No.
Right? They don't, because the big triangle just goes on past it. A is a shared angle because they literally overlap on that angle, right? That's what a shared angle is. So by shared angle, thank you, Daniel.
Can you put SAT?
SAT,
Yeah.
shared angle theorem?
Yeah.
Nah, it's not a theorem. It's a postulate. We can't prove that if they overlap, they're the same. SAP, shared angle postulate, but we already have one for that. Segment addition postulate, right?
You can do that?
Segment addition postulate is SAP. Shared angle postulate uses the same initial, so we don't do that. We just say shared angle, okay? Cool. Cool, cool, cool. All right, so now do we have enough angles to say this triangle is similar to that triangle? Yeah, we have a purple angle and a right angle, and the big triangle also has a purple angle and a right angle. Do you see it? Right? And again, it's because we ignore the DE line when we're looking at the big thing, right? Cool.
We'll do another retake.
Angle A. Letters are hard, guys. Sorry. Angle A, not angle C.
I was really fun.
Oh my god, I switched what they don't.
Right? It's not angle C. They don't share angle C. They share angle A. Does everybody see that now? I'm sorry.
Yes, you're.
Does everybody see
Yeah, you did
that now?
No, that's not.
Shut up. All right. By angle AA similarity. That's right. That's right. I should watch your profanity. All right. So these two angles is enough to get it done. I'm going to go small triangle first. Let's call it ADE to keep it alphabetical.
And ABC.
Now, if we match that up, angle A in the small triangle is purple. What's the purple angle in the big triangle? Also A, the shared angle, right? Angle D in the small triangle, well, it's not the right angle, and it's not the purple angle. So it's whatever's left over, right? What's the leftover angle in the other triangle? B. Turns out they will be congruent, right? We can prove that by CSP, but I don't care about the angles. They want me to talk about the sides, so I'm not going to bother with that. Angle E is the right angle in the small triangle. What's the right angle in the big triangle?
C.
C. So under is right, ABC.
I'm always right.
Are you gonna get him back today at lunch?
1, 2, 3.
I did clean up your mess. Yours and your table.
That wasn't.
I did it so the janitor didn't have to. So be bros next time. All right. So these two angles are these two triangles are similar? Let's talk about their parts. How do we talk about their parts? What do we use to talk about them? CSP, right? We can only do that once the triangles are similar, right?
I'll wear my.
So now that we've got that, we can use CSP. Let them in.
Yours isn't playing tonight.
AD is the same as what?
AB. That's
AB, they'll relate, right? They're corresponding.
Yeah.
And DE corresponds to
BC.
BC.
This is easy.
Daniel, have you ever tried not?
What?
AE
I wasn't even talking. I wasn't
and AC?
Yes.
Cool, cool, cool. All right. So we've got all those. Now, I don't care about all those, but it's true, so I might as well write it down. I want AD and BC. AD and BC are here and here. AB and DE are here and here. So I don't really care about the last guy, but that's okay. Right? So instead of rewriting this, what I'll do is how do I get BC moved over so it's with AD? Because that's what I want, right?
Multiply.
I multiply it over, right? I'm going to write AD times BC here. And then I'm going to multiply AB over as well. I'll write AB first because, again, commutative property allows me to do that. And now I'm done. Are we cool with that idea of multiplication? I don't need to see the work like I did in the last one, right? I just wanted to show you why it worked.
You did all the algebra in your head.
I did. I moved the BC over by multiplication, the AB over by multiplication, and I wrote it in the right order.
Can we do that on the test?
Yeah.
Oh, you can.
Yeah.
Can you run it
I
down?
want you to know why things go away because when things get more complicated, right? Knowing what's really going on is going to make the difference.
So you don't want us to rate.
I don't need it written, but I need you to know it.
Oh.
Okay? Yeah.
You might want to go back over that.
Yep.
Yeah.
That's fine. So see how this small triangle and the big triangle share angle A?
I just heard people say you're going too fast. So,
Gotcha.
Yeah.
Gotcha. All right. Gentlemen, put your phones away and be quiet. I think part of it is that you guys are too loud and they can't hear. Might not be all of it, but it's part of it. All right, so from the beginning, this triangle shares angle A with the big triangle. Everybody good with that?
Yes.
So now I can say that the small triangle has a right angle and a purple angle, and the big triangle has a right angle and a purple angle. So by angle, they must be similar. And I matched up their letters. Are we good up to here? Xavier, you with me? For real?
Oh, yes.
Getting called out by your cousin.
Whoa!
Right? You guys cousins, right?
No, definitely not.
Brothers,
I don't know.
aunts, uncles. Is Noah your dad?
This
Alright.
is my aunt.
Got it. That's fair. Like A-N-T. Okay. Then by CSP, we matched up the stuff.
See, what would a hermaphrodite be? An aunt or an uncle?
Whatever they want to be, I suppose. Right? Right? Exactly.
It's combination.
Exactly.
So we're here. And then we moved. So I don't need this because I wanted these letters, right? And then I moved that around by multiplication. BC, I times it over to AD. And instead of, to get rid of divides by AB, I times it over to here. Are we cool with that? Evan? Four. They said, yes? Absolutely. AC and BC are the same side. Alarm bells should be going off. ED and AC are perpendicular.
David, your favorite.
So we have two 90-degree angles here and here. Right. Cool. So those are all 90. That's what this means. We're going to get these sides. Now, which sides, or what triangles do we need to get similar? AD and BF belong to these two sides, right? Right here. So that's definitely these two triangles. If you needed any more confirmation, AE and BE are the bottoms of those triangles, right?
The line segment, that makes it a 90-degree angle.
This right here means perpendicular, which means it's 90,
Okay.
right?
Then,
The symbol here is perpendicular, and again, that means 90 degree.
So
Yep.
perpendicular automatically
It also
means that the
means-
angles are 90.
Automatically.
so
Perpendicular.
For isosceles triangle term, what would you write? Like IS?
So what we're going to do,
Just write it out.
I'll show you. So Andre's right. We have isosceles triangle theorem, right? Because these two sides are the same. That means the opposite angles here and here will be the same. So the way we would write that for abbreviation would be draw an isosceles triangle, right? Isosceles triangle have two sides together, right? And then THM I abbreviate for theorem, right? Isosceles triangle theorem tells us that angle A and angle B should be congruent in this diagram. Now, do we have enough information
Yes.
to prove this triangle and this triangle similar? Yeah, we do by angle, right? So by angle similarity.
That gets you every time.
Angle is probably the best, yeah. ADE will be similar to, now A is blue. What's the blue angle in the other triangle? B. And D is the right angle here. So what's the right angle in the other? F, right? E in this triangle is the unknown angle. What's the unknown angle in the other triangle? E. Now we know those have to go together because remember, similar triangles have congruent angles. So if they are similar, which we said they are, all the angles should be the same. Chloe, you all right?
Yeah, I just figured it out.
Cool. Right.
And I have
Awesome. So all those two triangles are similar, right? Now that we have that, we can use CSP, right? And get the sides. If they wanted to know about the angles, we could use CSP to prove E and E were the same, right? But they want to know about the sides, so we're going to use CSP.
What is that thing where it's like, if this is equal to that? and
Transitive property. So could we write all three sides out, right, in their pairs? Sure. But if you want, I only want AD and BF. Do they go together? Yeah, so I'll write that down.
What do you have to write for that?
And that should be equal to, by CSP. And then we wanted AE and BE. Do they go together? Yeah, first and third, right? So we can just write that right away. We don't have to write all the sides.
So you don't have to do anything else after that?
And now we're done, right?
Oh,
Because we got what they wanted.
Slack box.
Got what they want.
Yep, I know. The thing we were doing 2 weeks ago, I told you would be easy. It just takes some time. The stuff we did this week will take another 2 weeks, and then you will be fine.
Run it back, Turbo.
Run it back.
Run it back. Back up and go over it again.
Yep, run it back.
All right, we had this. So that gave us these two angles by isosceles triangle theorem.
Yep.
Since we have two angles now in both, we can say they're similar by AA. So I matched up their stuff. And then by CCP, I matched up their things here, right? Could I have gotten that DE and FE were the same too? Sure, but I didn't need it, so I didn't write it.
How come the ones we did on the review were like so much?
These are literally the worksheet we've been doing. The exact same
Why
problem.
are you doing this so short this time? Or you're not doing algebra?
Maybe you should just pay attention more of the time. I'm not saying you don't. I'm just saying you don't pay attention all of it, so maybe do a little bit more.
I'll consider that.
Yep. None of y'all, I don't care how smart you think you are, none of y'all are smart enough to do this without me. Guaranteed. That's why you're in the class, right? The stuff we did first semester, yeah, you could BS your way through it a little bit.
This page needs to go.
This you can't. AC and BC are congruent.
Wait, did Alex get the right absent on this quiz now?
Why?
Since he missed part of the
Nope.
last period?
Mm-mm. We also know that CD and AB are perpendicular, right? And perpendicular means what? Oh, come on.
What?
Perpendicular means what?
90.
90. So we have 90 degree there. Now, if we know that's 90, don't we get the other one for free as 90? Right? Because they're a linear pair, and they have to add up to 180. So if one's 90, the other has to be 90. That's what this stuff means. Again, one of the reasons I use colors is so you can see... Shut up. One of the reasons I use colors is so you can see... Luke. So you can see what stuff was given, right? I was given the purple stuff, and I was given the red stuff. We also have FE and AC are going to be perpendicular, so that's this. FE is perpendicular to AC. So again, we get two more 90-degree angles. Cool. Now, we're in Triangle City here. There's 1, 2, 3, 4, 5 triangles I can see. These guys are not triangles, right? They're quads. Which ones do we want to get similar? Well, if you look, we want AE, which is this side here. And it definitely belongs to this big triangle. That's the only triangle it belongs to. So we definitely want the one that's laying down, right? AC, well, that belongs to both this big triangle here and the whole triangle, right? So we're not sure which one we want out of those two. AF further confirms we want the one laying down, right? And then AD belongs to, only this triangle, right? It also belongs to this quad, but again, we don't know anything about quads. So AD tells us we definitely want this triangle. AF tells us we definitely want this one. AC further confirms we want this triangle, right? And then AE further confirms we want this triangle as well. So, Chloe, AE only belongs to this one, right?
Mm-hmm.
AC belongs to both this guy and the whole thing, right?
So can't we do like by shared angle?
Yeah. I just want to make sure you know which triangles we're going after, okay? Now, it's confusing at first because you don't know AC just tells you this guy or this, right? But after we learn that AD is something we want, that really confirms that this is the triangle we're going after, right? We want this triangle here, ACD, and we want this triangle AEF to be similar. Could we get others? Sure, but those are the ones we want. So, right now, triangle laying down has a right angle in it. These don't count, right? Has a right angle in it. Triangle here has a right angle in it. Again, these don't count. We need one more set of angles to get that done. What do you see? They share angle A, this triangle here and this triangle here. So you could do shared angle and get this. You could have also done these two sides are the same, so these two angles are the same. Right? No one would have gotten you that. But either way, let's do shared angle. You didn't even need that, did you? Angle A is congruent to angle A. So we've talked about angle A. And then we were given the 90s for free, right? So now we have a purple angle and a 90 in this triangle. And a purple angle and a 90 in this triangle. So by AA, they're similar, right? Let's go with the laying down triangle. Actually, we'll go with the standing up triangle first. So how about ACD? I try to keep it alphabetical for my first triangle, just so things are consistent. You could call it DCA if you want, or ADC. Now, since I said A first here, now look at our big triangle, standing up. A on our triangle laying down is the purple angle. What's the purple angle on our triangle standing up? Also A, because they share it, right? Now, C in our triangle standing up is the unknown angle, right? It's not the right angle, it's not the purple angle, it's the leftover, right? So what's the leftover in our triangle laying down? F. What's your profanity? D in our triangle standing up is the right angle. What's the right angle on our triangle laying down? E, not D, right? E is in that triangle. Okay? I'm glad it's finally clicking. That's good. All right. The same spiel every day. Literally the same problem. All right, so here we go. So we got this. How are we going to get that? Well, we're going to use CSP, right? Now, AC and AF go together. Do I care about AC and AF?
Of course not.
Yeah, so let's get them done. AC and AF. CD and FE go together. Do I care about CD and FE up here?
Do you
No.
have to do that?
So you can write them down or not. I don't care. Right? You can write CD and FE here. But we don't really care about it, right? So why?
Yeah.
Now, AD and AE go together as well, right? Because they're first and third. We do care about AE and AD and AE, right? So we'll write those down. Now, AD came from my first triangle. That's what I write on top. And AE came from my second triangle, so that's on bottom. You could flip those if you want, right? Just be consistent. If you did the first triangle on top, make sure it's always the first triangle on top. And then what do we do to get it to look like this? We're going to multiply, right? We're going to do algebra, right? We're going to do math. So I'm going to write AE first because that's what they wanted, times AC. And then I'm going to multiply AF over, and I'll write that first, AF times AD. Right? Just another way to write division is multiplication. That's it. How you guys like the big screen? Yeah, I'm sorry that it took so long. I rewatch at least one stream every night, and I've been thinking for a while, like, it's such a pain you don't get the full screen view. How you feel? Yeah? Strawberry. All right. Number 6. Here we go. D is the midpoint of AC. So that means, well, if D is the midpoint, it means the halfway point between A and C. So doesn't that mean it cuts AC into 2 equal pieces? Right? That's what that means. Yep, D is the midpoint, right?
You don't really need that.
No, we'll need it. E is the midpoint of AB. So if I go to AB and E is the middle, then I know that these two are congruent, right? Before it looked like they were congruent, but this tells me it is. How do we feel about that so far?
Shared angle.
So, which triangles do we need to get together? Well, we only have 2 here. We have the big one and we have the small one, right? But we want BC and DE. So BC is this side, right? And DE is that side. So yeah, those are the 2 triangles we need, right? Those sides belong to those triangles and those triangles alone. Could we get more information? Sure. But that's what we want, right? We also want to prove that BC and DE are parallel. That'll be interesting, okay? Don't forget that. I think we're pretty good with this by now, right? Getting this is going to be weird, okay? So let's get them similar and then work our magic. What do you see, Evan?
If you use the triangle theorem thing, you can get the angle C and angle B.
Nope.
Angle, what?
If I add those 2 together, they're double red, and that's double blue. If red is a different number than blue, like if those are both 3s, then this is 6 in length, right? And if those were both 5, this would be 10, right? So they're not necessarily isosceles. Do you guys see that? Yeah. Right? If they're both reds or both blues, then yeah, right? But they're not.
Well, then shared angle A.
Yeah, shared angle, right? Again, vertical angles, linear pair, and shared angle, you're going to find them everywhere. Ask yourself, is it actually going to help me? Well, angle A is shared for both the triangles I'm interested in, right? So yeah, that will help me. So I'll write it down. Both the small triangle here uses angle A, and the big triangle uses angle A, right? They perfectly overlap. So we call that bi-shared angle. And we're going to say angle A is congruent to angle A. And we can call it just by its first name, first letter, right? Because there's only one angle A in this diagram. There's not multiple. Notice how angle E has 2 angles, right? And angle D has 2 angles, right? So you couldn't call that angle D. But you can call that angle A. All right, so do we have enough information to prove that these triangles are similar? We don't have 2 angles, right? We have 1 set, right? But we do have enough because we have 3 ways to prove triangles similar. Double A, which we use all the time. Side angle side, and then triple side, right? This is side angle side. Now notice we're not saying the sides are congruent. We're saying that the sides are related the same way. Isn't this half of this?
Yes.
And isn't this also half? Well, if they're both half, then they're both proportional, right? If that was a third of this whole thing, and that was half, then they wouldn't be, right? But because they're both half, then they are related. Does that make sense?
Wait,
Yeah?
So, if E is the midpoint of AB, then AE and BE would have to be the same width.
Yep.
Which means the two triangles would have to be congruent.
Okay, exactly. So here's what you're missing. I'm saying that this is half of this, both together.
Oh,
And
never mind.
this is half of this. Yes, they are both the same here and here, but I'm talking about the triangles, right? Here is half of the whole thing. Here is half of the whole thing. So I'm going to say AE relates to AB, right, the whole thing, the same way that AD relates to AC, its whole thing, right? They're both by half. So I'm going to say AD, and this doesn't take any proof or theorem or anything. This is just pointing out what's true. AD relates to AC the same way that what? AE, bless you, relates to AB, right? Namely that they both relate by half. Now, could you have flipped those and got double, right? This side is twice as big as that side, right? You could say it that way too. That would have been AB over AE. And you notice that's the flip of this, right? Well, if I flip that 2, then it's 2 over 1. Notice that the way I wrote it, it's 1 versus 2 reds, right? So it's 1 on top, 2 on bottom. AE, 1 on top, 2 on bottom, okay? If you start with the small triangle on top, make sure you have the small triangle here too, right? Just be consistent. Now they want double, right? And I got half, so I'll have to flip it later, but that's okay. Now they wanted to know about BC and DE. I don't have any of that here. But luckily now I have 2 proportional sides, right? A red side and a blue side. And I have an angle in between, right? So I can use SAS similarity to say the triangles are similar, and then I'm going to get these sides by CSP. So I'm going to say this is similar to that by side angle side similarity, side angle side similarity. And then I'll use CSP to get the other sides.
Can you write down like by SAS and then CSP before you write down that, or just
No, you have to have the angles and the sides. That way you can use side angle side. Does that make sense? Right, I have to have talked about the sides and the angle before I can use side angle side.
you can't say that similar?
What triangle?
So right off the bat, I didn't have that angle, right?
So you know.
And I hadn't said anything about the sides, that they were related. You have to point that out.
Okay.
And then you have to point out the angle in between. Does that make sense? And now that we've addressed that, we can say, since I have 2 proportional sides and an angle in between, I can use side angle side similarity. Great question, Chloe.
So why don't you have to prove the learn
I
the
can't hear.
sides? So why
You
don't-
two in front, please. I can't hear.
Why don't you have to prove that they're similar?
I need to prove they're similar because I'm interested in BC and DE. And notice I didn't get that.
Yeah, I meant like when you wrote those down, why didn't you have to prove that?
Say it again.
When you wrote down AD over AC is equal to AE over AB, why didn't you have to prove that?
Oh, so we know that just by math. This has to be half. So if this was like 3, then that has to be 3 as well because they're congruent, right? Well, 3 is half of 6.
So do you not have to prove it because it's
No, yeah, it's basically given, right? We're
Okay.
extracting that information from the diagram. Good question. Good question. Andre.
So I did by cap.
Hold on, we're not there yet. By side angle side, we got to get these triangles similar. So I'm going to write the small triangle first. That's triangle ADE.
That's what I did before. So I didn't do SAS. I did by cap after shared angle. And then
Can't use cap. You don't know those are parallel. Right? Okay, cool.
All right.
All right, so ADE is similar to A is the purple angle in the small triangle. What's the purple angle in the big? A. And then D is made up of the red side, and because they're both unknown, so we gotta have a different way to identify it, right? Red side and unknown side. So if you go to the proportional red side and the proportional unknown side, that's gonna be angle C, right? E is blue and unknown. Proportional blue, proportional unknown. It's gonna go with B. Right. Now,
Does it
What?
have to be in that order? Like
if you do ADE over
No.
here,
the AD over AC, that stuff, does that have to
you could have had them opposite.
Because I put SAS before that. SAS
No,
similarity.
guys, same question she was just asking. So you need to show that 2 of the sides are proportional, right? That they're proportional, right? And then once you have the 2 sides and the angle in between, now you can say, I had 2 sides and angle in between, so by SAS, they're similar. You have to address the sides and the angle first, okay? Whoa.
Oh,
If they're similar, then they're parallel.
Cool. Does that make sense? You have to address that first. So now that they're similar, you're right, we're going to get there. So now that they're similar, first let's get the sides, right? We know that AD and AC should be the same, right? Now if you notice, didn't we already have that? So I'm going to write it again. And I'll write it in red so you see the connection. I also know that DE and CB are the same. Now I didn't write that before, so I'm going to use a different color. DE and CB should go together. And that's what I wanted, right? Basically, just the flip of that. And then I also know that AE and AB go together, right? And now if I know what AD over AC is, and I know what AE over AB is, right? They're both a half, right? And they equal this guy. Don't they all equal a half? Right, and that makes sense, because if triangles are similar, then their sides should all be proportional. They're all related by a half, right? They have to be. If they're similar, which we said they are, right? Then all the sides should be related by a half. Otherwise, they wouldn't be similar, right? So we get that. Cool. I'm gonna flip everything, right? So I get 2 instead of a half. Remember, it really is how you talk about it, right? I went from small to big. AD is half of AC, right? If I flip it, it'll be AD or AC is double AD, right? Again, just flip everything. I'm gonna flip just the green part. We're allowed to do that. That's just math. Also, I'm gonna write BC instead of CB, just because that's what they have. Notice that CB and BC are the same thing, right?
Oh, so
It's the same name. They wanted BC, so I'm gonna write BC. Do you guys see how BC and CB are the same?
What
Jesse,
does
would
that
you?
equal?
Oh, thank you. 2 over 1, which of course equals 2. Now we're done.
So we gotta get BC and DE perpendicular.
Yeah, we got to do that as well, right?
that'd be by.
Oh, sorry. Done with that part.
That'd be by CCP.
Sorry, guys. I'm trying to fly. I'm making mistakes. That's my bad.
E by definition, maybe.
Well, in theory, this is the 3rd time you've seen this. What?
Could you use like by definition, they are perpendicular?
So check it out.
I don't know.
We know that Cap says if we have 2 parallel lines, then if a transversal cuts them, then the corresponding angles will be equal, right? For example, these 2 corresponding angles, right? That's Cap. Everybody cool with that?
That's Cap.
Now, Cap also has a reverse, right? Now, not all theorems reverse is true, but Cap converse is true. So instead of the parallel lines get us the angles, it'll be the angles, if they're congruent, what must that mean about these 2 lines?
Yes, the parallels.
They must be parallel, right? This is Cap,
Oh, yeah, parallel.
and this is Cap converse.
So you wouldn't do CSP, you'd do cap.
So if we had 2 angles that were congruent with a transversal cut by 2 lines, right, then those lines must be parallel. So to prove these are parallel, here's what I'm going to do. I'm going to prove that angle and that angle are the same. Because if they are, don't we have a transversal cut by 2 lines, right? If those 2 angles are the same, then those must be parallel lines, right? You could also do it with these angles. What do you want to do, top angles or bottom angles? Yeah, what's your question?
How is a Cap converse reversed? Because it looks the same.
So Cap says if we have parallels, we get the angles, right? Cap converse says if we have the angles, then these must be parallel,
Okay.
right? Yeah, it's kind of hard to just look at it, what I wrote, because it looks the same. It's what order I wrote it in. All right, so if we can get angles, then we can use Cap, right, and get parallel. So what I'm going to do is I'm going to use CCP again. Oops. CSP, right? I'm going to use CSP again, right? That was CSP. That's how we got that. I'm going to use CSP again. And this time I'm going to talk about the angles, okay? So I'm going to zoom out a little bit so you can see. Can you still see? So again by CSP, let's match up some angles. Now, you wanted to work with the top 2, right? Well, that top angle is ADE, right? So if I look at ADE, that's first, second, third in my triangle, right? So it should be congruent to whatever angle first, second, third is on here. ACB, ACB. Oh, look, right? They have to be. See how the letters match? Could I have done the bottom and done AED? Yep, I do first, third, second. First, third, second is ABC. ABC. Yeah, they would go together, right? After you get the triangles are similar, you can use their letters to get their parts, right? their angles or their sides. So by CSP, I'm going to write that angle ADE must be congruent to angle ACB, right? Because they're both first, second, third. It's very convenient when they're in the, one after the other order.
Okay, then that, and then by cap converse.
And so those two are the same. I'm going to mark those. That's this guy and this guy. And then do I have two lines cut by a transversal where the corresponding angles are congruent? Yep, then the lines must be parallel, right? So by cap converse, line DE is parallel to segment BC. Ooh, they wanted BC first. Either way. Boop. Right? Do it in the order they want. And now we're done with the whole thing. That's probably the weirdest part. We feeling okay about that?
Oh, this one.
Well,
Yeah.
we get points taken off if we put like the AB is parallel to BC.
Probably a half.
Okay.
Flip it. Pythagorean theorem. Guys, we're probably not going to have enough time to do this. That just happens sometimes with the review. We've done it before. No, I will put it on the test.
Oh, this one's the.
Here's the deal. They give us this is 90. If you want, watch the other reviews, because I'll get through it for them. And they said that this was 90. Because you guys are too talkative and had questions, and that's fine. The talkative part, probably not, right? But you screwed yourselves. The questions part, that's fine, right? So, these two angles are 90. We also get that this one's 90, right? If that's 90, because they're a linear pair. Now, we want to prove A, B, and C. So what we're going to do is we're going to get all the triangles similar. Small to large, medium to large, and large to medium. Then get their parts. I would encourage you to watch the other reviews. Yes.
I might.
Yeah, me too. Can I have another one too, please?
Absolutely. That's why I put an extra.
Yes.
We're learning how to do it.
I want to make sure I'm doing it right.
Absolutely. Oh, sorry.
Is right back coming after school?
Yeah. Why wouldn't you? Yeah. I'm always here.
Have you ever met Mr. Nestor? Hey, can I have one of those?
I want to what? Yes.
Have you ever met Mr. Nestor?
No.
That's probably gotta meet him. You and
I'm
him
writing
are,
by
like,
CCP.
so similar.
Yes.
You've got to
To
meet Mr.
Homer.
Nestor.
They're not similar at all. I don't know what you're talking
He was
about.
in the building next year,
G1.
subbing for bio.
They definitely are similar.
Should've been. He should've been.
I need this break. I need this weekend break. I'm losing my goddamn.